Okay, let's do the 14th. That is derivative of sine x plus a. You see, we already know the derivative of sine x is d by dx of sine x is equal to cos x, okay? But here you see it's x plus a. Instead of x, it's x plus a. So we have to use the chain rule here. That is, if you see, assume a function to be x or x, then we have to derive it again, multiply it and derive it again, okay? That is, now assuming this to be x, let's assume this to be a single variable, okay? Let it be x, then sine x will be cos x. So derivative of sine x plus a will be cos x plus a, because we are assuming this to be a single variable. Now since we are assuming it, we have to derive it again and multiply it, okay? So d by dx of x plus a, okay? So derivative of x will be 1 and derivative of a will be, a is a constant, it will be 0, okay? Since a is constant, it will be 0. So we can write this cos x plus a, derivative of x will be 1 and derivative of a will be 0. So 1 plus 0 is 1. So cos x plus a multiplied by 1 is cos x plus a, okay? That's it. See, we got the same thing. See, for example, if it's not x plus a, if it is something else, see, we'll take an example. See, if it's sine, say it's 2x squared plus a, okay? Then derivative of sine, this will be, assuming this to be x, okay? Then we have, according to sine x, derivative of sine x, it is cos x, so we write it as cos 2x squared plus a, okay? Since we are assuming it and this is not x, so we have to derive it again. So we will write it as d by dx 2x squared plus a, okay? So this will be cos 2x squared plus a. Now derivative of this will be, 2 will be brought out, and derivative of x square plus a, derivative of a will be 0. Now cos 2x squared plus a, this will be 2x raised to n form. So we will have 2x raised to 2 minus 1, okay? So this will be 4x. So cos 2x squared plus a multiplied by 4x, okay? Since this is the angle of cos, so we normally multiply, the multiplication will be brought to the left hand side, because it may get mixed with this, with the angle. So we write it as 4x cos 2x squared plus a, okay? This is how it is done using the chain rule, okay? Now let's do the next one, that is the 15th one. That is derivative of cot x multiplied by, sorry, cosecant x cot x, okay? So cosecant x cot x, these are two functions, multiplication of two functions, okay? So for that we use the u dot v formula, okay? Form, considering this to be u, the first function, and the second function to be v. So u dot v, or d by dx of v, or of u multiplied v, will be derivative of the first function u multiplied by v, the second function, plus u, the first function, and multiplied by derivative of the second function v, okay? Instead of u v dash, we use now this notation, okay? Let's practice this also. So it will be derivative of u, that is u is cosecant x, so d by dx of cosecant x, okay, multiplied by v, the second function, that is cot x, then plus u, the first function, cosecant x, then derivative of the second function, d by dx of cot x, okay? Now according to formula, the derivative of cosecant x is minus, no, cosecant x cot x, okay? So it's minus cosecant x cot x, and this cot x as it is, cot x, plus, now this cosecant x as it is, the derivative of cot x is negative cosecant square x, okay? Okay, now we write it as cosecant x this cot and cot gets multiplied, it becomes cot square x, and this negative and this positive gets multiplied, it becomes negative, and this both get multiplied, it becomes cosecant cube x. Okay, square and 1 cosecant x become cube x. Okay, that's it. This is the answer. Now we can write this according to the highest power. So this will be written here, minus cosecant cube x, then the next one cosecant x cot square x. Okay, that's it. This is the answer. Now let's do the 16th. Okay, now this is two functions in the division form. Okay, or quotient form we can say. So this will be, we'll be using u upon v. Considering this to be u and this one to be v, we'll use u by v form. Okay, so u by v whole dash is equal to u dash v minus u v dash upon v square. So here also let's use the notation d by dx. Okay, so d by dx of u upon v, instead of dash we'll use d by dx. V is equal to derivative of the first function d by dx of u, then multiplied by v minus u as it is first function, then d by dx derivative of the second function v upon v square. Okay, now let's bring this to, put this in the formula. So u derivative of cos x, d by dx of cos x multiplied by v, that is 1 plus sin x, minus u, that is cos x. Okay, derivative of v, that is 1 plus sin x upon v square, that is 1 plus sin x whole square. Okay, now according to the formula, derivative of cos x is negative sin x. Okay, sin x, this second function as it is, minus cos x first function as it is, derivative of this will be, derivative of 1, a constant, will be 0, so 0 plus derivative of sin x will be cos x. Okay, upon 1 plus sin x whole square. So now multiplying this inward, you will get negative sin x, and this negative sin square x minus cos x. So cos x plus 0 is cos x, so cos x and cos x will be cos square x. Okay, upon 1 plus sin x whole square. Okay, sorry, sin x whole square. Now you see we have sin square x here and cos square x square here. So let's take negative common, so we'll have minus sin x. Let's take this one, the negative sign of this common. Okay, so it will be, so this as it is, negative sin square x plus cos square x. Okay, that is, now negative is common here, upon 1 plus sin x whole square. Now you see this is sin square x plus cos square x, which is 1. Okay, so we can write this as 1. So it will be minus sin x minus 1 upon 1 plus sin x whole square. Okay, now you see here also again you have two negatives. Let's take the negative common, so it will be negative sin x, negative common, so sin x plus 1 upon 1 plus sin x whole square. Now see, this is 1 plus sin x, this is sin x plus, both are same. Okay, or you can write it as 1 plus sin x upon 1 plus sin x whole square. So 1 plus sin x here, and 1 plus sin x, 1 will go, so you will have remaining minus 1 upon 1 plus sin x. Okay, so this is the answer.